It's an interesting question on projectile motion where we're given partial information, the horizontal component of the initial velocity, but in terms of d, and then how long it takes the projectile until it hits the ground. Okay, I'm going to draw a little sketch of what's going on. So it's going up at an angle and then coming back down. Got some sort of velocity, and we can split it into horizontal and vertical. So this vertical is 5 over 3d. And then we're told the time is 2.4 seconds. So I'm going to I'll say that this is O and this is A. We're going to apply suvat from O to A. And because I've got information about the horizontal direction, that's what I'm going to look at to start with. We're asked to work out in terms of d, the horizontal distance. So that's what I want to find. And I've got that u is 5 over 3d. Now horizontally, acceleration is 0, and therefore the final velocity is also 5 over 3d, and t is 2.4. So basically our Suvat equations kind of collapse and just become s equals ut, because you can take s equals ut plus a half at squared, but a is now 0. And therefore s is going to be 5 over 3d times 2.4, and that becomes, put it in your calculator, 4d, 5 over 3 times 2.4. To show you. There we go. So that is our answer for the first part. The second part asks us to find the vertical component of the initial velocity of p. So I'm still going to be going from O to A because that is where I've got most information. Right, but this time S is actually going to be 0. The vertical displacement is 0 because I've gone all the way up and back down. U is what I want to find. A is minus 9.8 because I'm applying suvat up, and T is 2.4. So what do I want to apply? S equals ut plus a half at squared. So 0 is going to equal 2.4 u. Then it's going to be minus, like a half times minus 9.8 is minus 4.9 times 2.4 squared. So I just can't quite fit that in. And then u is going to therefore be 4.9 times 2.4 squared over 2.4. In fact, that just cancels. So it's just 4.9 times 2.4. Which is 11.76. Now the answers actually leave it as 11.76, but really we should be rounding our answers to 3 significant figures here because we're only using gravity correct to 2. So I'm going to write it as 11.8 meters per second, or just 11.8. That is A and B done. We're then told that the particle just clears the vertical wall, which is situated at a horizontal distance d from O. So we've worked out that the whole distance is 4d, and therefore this wall probably is going to be around here. It doesn't really matter, but there it is on my diagram. And we're asked to find the height. So I'm going to say the position here is now B. I'm going to apply suvat. Is this part B? This is part C. That was part B. So I'm going to be applying suvat from O to B. Just clear it, and we're told the horizontal distance is D. So let me first of all look at the horizontal component again. We'll see if we bring the other one in. S is going to equal D. Remember, u is 5 over 3d. A is 0 and v is 5 over 3d again. So, okay, so I'm using a very similar sort of formula. Um, so S is going to equal ut plus a half at squared, but A is 0. Therefore, D is equal to 5 over 3d times t. I can cancel out, I can divide. It's going to be t is 3 over 5, or 0.6. So I now know the time at which it passed over the wall. I can bring the vertical component back in now. So applying Suvat up. So that 0.6 is the link into the vertical part. It's still 0.6 here. A is still minus 9.8. And now, remember, I know the initial vertical velocity. Okay, so that's useful, 11.76. I'm not going to use the 11.8. That was just a rounded version. I'm going to use this exact version. So I've got everything I need to work out S from this. S equals ut plus a half at squared. Half of minus 9.8 is again minus 4.9 times 0.6 squared. We get 5.292, which I'm going to round to 5.29. So that's the height of the wall. It's just going to go over the wall. Um, so you could argue it's like the wall's going to be slightly less, but it's absolutely fine to leave it like this. Remember, we're dealing with like a particle rather than like an actual thing with dimensions. Okay, brilliant. So finally, we're told that the speed of P as it passes over the wall is 16 meters per second. I'm asked to find the value of D. So that this is gonna we just need to work out. Right, basically we have we're still looking at O to B, but now we know the speed is 16. So momentarily at point B, we've got a velocity or speed of 16. We know the horizontal component is 5 over 3d. We don't know the vertical component though, do we? Just trying to think. No. So that's what we want to find here. V is going to be u plus at. That's the best one to use. So it's going to be 11.76 minus 9.8 times 0.6. Which is 5.88. So yeah, we have the speed. But given the speed at that point, we've got the horizontal component of the speed already in terms of d. So I just needed to work out the vertical component of the speed at that point. because now I have a right angled triangle and I can use Pythagoras to link the three of these together. It must be that 5 over 3d squared plus 5.88 squared is equal to 16 squared. Therefore, 25 over 9 d squared is going to be 16 squared minus 5.88 squared. Two two 1.4256. I can times through by 9, divide through by 25. 79.71, that's my value of d squared. Okay, goes on. So d is going to be the positive square root of this. 8.9282. Which to three significant figures is 8.93. I enjoyed that question. Slightly different variety of projectile question. Well done.